Determine the period of small oscillation of a pendulum such that the ball is suspended by a thread of length 20 centimeter. Length of the thread is given to us, that is 20 centimeter. If it is located in a liquid, it is located in a liquid whose density is eta equal to 3 times less than that of ball. Means if I say let the density of ball is x and the density of the liquid is 3 times less, so it is x by 3. The resistance of the ball is to be neglected. Now, we all know this is a situation of the simple pendulum, and time period of simple pendulum is given by 2 pi root L upon G effective. अब G effective कैसे निकालोगे? अगर इस बॉल पे आप देखो तो नीचे की तरफ वेट लग रहा है, दैट इज mg, ऊपर की तरफ क्या लगेगा, बायनेंसी fb. तो नेट वेट विच इज एक्टिंग इन द डाउनवर्ड डायरेक्शन, दैट इज mg डैश, इज गिवन बाय mg माइनस बायनेंसी. यहां तक आपको लॉजिक समझ में आ गया होगा. इनटू वॉल्यूम, डेंसिटी इज x, वॉल्यूम इज v इनटू g, माइनस बायनेंसी, buoyancy density of the liquid into volume into gravity. So we will solve it. It will be 2 by 3 x v into g. So this is mg dash. Now effective gravity, that is g dash, it will be written as 2 by 3 x v g upon mass. Mass is again density into volume, so it will be 2 by 3 into g. Put the values here. T equal to 2 pi root L की जगह लिखोगे 20 centimeter, so it is 20 by, we can say 100 meters, and gravity effective is 2 by 3, so this is 2 by 3 into g. G को मैं ले लेता हूँ 10. So when we solve it, it will be T equal to 2 pi root, then you can say this 20 is cancelled, so I will say it is 3 by 100. 2 pi root 3 by 100. Now further we will solve it. It is 2 pi root 0.03. Now we will solve with the help of the calculator. After solving, we will get it is 1.09 second approximately. So final answer of the problem will be 1.1 second.